Let's continue the same problem. Say, let's second equation, second compatibility condition we have to write down. Substitute the values here. So this is minus 92 upon EI plus F21 is 2 upon 3 EI Q1 plus F22 8 upon 3 EI Q2 equal to 0. Now the second equation, say EI gets cancelled, so multiply by 3 everywhere, this 2Q1 plus 8Q2 is equal to, say equation multiplying by 3, so equation 2. So now we have to solve this equation 2 in order to find out Q1 and Q2. So if you solve this two simultaneous equations as usual, so there is no problem, but this is a matrix methods, and in order to write a program, generally we use the matrix approach to solve the equations, because these two equations are written in matrix form. How we write down them? This is 4, 2, 2, 8, and this is Q1, Q2 equal to, this is 96, 276. So in matrix form we can write down the equations in this. So now let's find out inverse of this. This is Q1, Q2 is equal to 1 upon, inverse means 1 divided by determinant. So what is the determinant? Is 8 into 4 minus this 32 minus 4, 28. So this is 28. So then say, now these two are to be interchanged. These two are to be interchanged. This is 8, and here change the sign, minus 2, minus 2. So this diagonal interchange the elements, and second diagonal change the sign. So we will get direct. So this direct, for 2 by 2 matrix only we can find out the inverse direct. If unknowns are more than 2, then finding out inverse is very difficult. So in that case, how to solve the equation? So by regular procedure you solve the equations, but generally the syllabus, in the syllabus it is mentioned that the maximum number of unknowns should not be more than 2. So 2 or less than 2. So only 2 by 2 matrix, how to get the inverse, that only you practice. So this is to be multiplied by 96 to 76. So what is then Q1? Q1 is equal to 1 upon 28 into bracket, this 8 into 96 minus 2 into 276. And then Q2 is equal to 1 upon 28 into bracket minus 2 into 96 plus 4 into 276, so equal to. Now this you find out answers. I don't have answers, but we can calculate them. There is no problem at all. So first one is 8 into 96 minus 2 into 276. Divided by 28. 7.71. So this comes out to be 7.71 kilonewton meter. So answer is positive, means assumed direction is okay. Q1 is this. And then the second one is minus 2 into 96. So this is minus 2 into 96. Then plus we can find out this 4 into 276. 4 into 276 equal to divided by 28, 32.57. So this is also positive, means assumed I have 32.57 kilonewton meter. So what we get is say we have calculated the moments. Say this, now you can write down these values at the end. So this is 7.71 kilonewton meter and this is 32.57. Now with these values, let's draw BMD. At least the BMD we can plot easily because we have a pre-BMD already plotted. So this was 724 and we already constructed. This was 60 and here 32, somewhere here 32.57, here 7.71, here it is 0. So this is BMD. So if you want to construct SFD, then you find out reactions by using equilibrium conditions and then you construct SFD also. Okay, now one more problem. This is the problem of beam we have solved. So let's see one problem on frame. Suppose hinge shear and it carries a UDL, say 12 kilonewton per meter, this is 4 meter, say this is 3 meter. So this is a problem. Analyze the frame by using flexibility method or force method. A, this joint is B, this is C. Now SDI is 2, this is 3, here it is 2, 5 reactions minus 3 equations, SDI is 2. So let's select the 2 reactions here, these are the positive directions I have assumed, Q1, Q2. Means what I did is let HC equal to Q1 and VC equal to Q2. So horizontal reaction and vertical reaction at support C I have assumed as unknowns. Okay. Now what is required here is construction of BMDs. So first remove the support, release the structure and then you obtain, so this is the UDL W per meter run. So this becomes just like a cantilever beam. This is free end. So what will be the diagram? So I will construct, or if you want separate diagram, say here, and see in case of frames what we will do, draw BMD on tension side. Draw BMD on tension side. Draw BMD on tension side. So this will cause, because this is a hogging, say this is fixed support, so it causes tension upward. So draw BMD on tension side. This is parabolic type since UDL, and this 12, actually this is 12 kilonewton per meter. So 12 into 4 square upon 2 is the bending moment here. So this is 96 upon here. So this is 60 So 96 upon EI. Then this will be M upon EI diagram due to loading. This is M upon EI diagram. So next what you do, let us consider unit load. For flexibility coefficient, this is fixed, remember, Q1 is in this direction. So apply a unit load in the direction of Q1. Apply unit load in the direction of Q1. And see, this will cause tension inside. So here, the bending moment diagram will be like this. And this ordinate is 3. Again, for horizontal member, it causes tension inside. 1 into 3 diagram will be like this. So this ordinate is 3. So this is here 3. Now either we consider positive outside or negative outside, anyone. So here see, the outward we will consider negative. This is negative. This is inside, let's consider this as positive. Inside take positive, outside of the outside diagram of frame take negative. Then in the next case, what we do, let's apply a unit load in the direction of Q2. Apply unit load in the direction of Q2. And draw BMD, it's again fixed at one end and free at other. So here there is no bending moment because the line of action of load passing through the axis of the member. So only you will get, and tension bottom, linear diagram you will get. Here it is 0 and this is 1 into 4, this ordinate is 4 and this is again positive. This diagram is positive. So this is M upon EI diagram, this is M1 diagram and this is M2 diagram. M1 diagram, M2 diagram. Now the rest of the things are very simple. So dQ1L equal to integration M upon EI M1 dx. It's nothing but area of M upon EI diagram. So its area, this is cubic, 1/3 minus 1/3, base is 4, height is 96 upon EI. It's cubic curve, like cubic parabolic, inverted parabolic. So 1/3 base height. Now ordinate of M1 diagram at the CG of this diagram. So M1 is rectangle. Wherever you take the ordinate, it is 3. So this is plus 3. So you find out this. Answer is minus. Then dQ2L equal to integration M upon EI M2 dx equal to, now here again same area, so that is 1/3 base height into ordinate of this diagram, M2 diagram at the C. Now CG is required. So it's CG, so it is 1/4 from this end, that is length divided by 4 and 3/4 of 4 from this end. Base is 4. So that means 3 meter. So 3 meter means it's so at a distance 3 meter, what is the ordinate will be 3. So ordinate will be 3. So multiplied by again 3 equal to. Okay, this will be again negative. So I think we will do these calculations. Then F11 equal to integration M1 upon EI M1 dx. This is, now here we have to consider this rectangular base into height, or height 3 upon EI. Whenever we consider area, that height divided by EI. So M upon EI we will get, and its ordinate, its own CG is 3. So you write this, then F12 equal to F21 equal to F21. So consider, let us consider area of this. This is 1/2 base height 3 upon EI. This area, no, height is 4. 4 upon EI. 1/2 base is 4, height is 4 upon EI. And ordinate is 3. Because this is rectangle, so ordinate is 3. And that's all. We have only one figure here. So this, and last, F22 is equal to F22. So the area into, so this is 1/2, base is 4, height is 4 upon EI, and ordinate at their own CG. So it's a CG is 2/3 of base. So CG of this diagram is 2/3 base from this end, that is 8/3, or 2/3 divided by divided by 4 equal to this divided by, again this divided by 4 equal to this divided by 4, 8/3. So this you will get 8/3. So now we have calculated all displacements. Let's use compatibility conditions, that is dq1l plus f11q1 plus f12q2 equal to 0. Then dq2l plus f21q1 plus f22q2 equal to 0. So we'll get these two equations. Let us develop two equations. Solving them, find out q1 and q2. So this you get the reactions at C, HC and VC. Once you get the reactions at C, then you calculate by equilibrium conditions reactions at A, summation Fx equal to 0, summation Fy equal to 0. Then calculate bending moment at B, bending moment at A, and then you construct bending moment diagram. This is the rest of the procedure. But I think after getting Q1 and Q2, that is a horizontal and vertical reaction at support C, further you can do calculations yourself. Now one more problem, let's consider, because we are going to concentrate more on stiffness method. So flexibility method actually is not used for programming purpose, so we will not waste much time on this. Say one more problem, let's consider. Say this is fixed here, say hinge support, and say 40 kilonewton meter. Say you take this as 4 meter, this as 3 meter, this is A, B, C. So this is the problem. Now the beam is subjected to concentrated moment at hinge support. Say suppose instead of hinge roller is given, then only one unknown. Here hinge is given means two unknowns. Two unknowns means let's assume Q1 and Q2 reactions here. Say whatever is the direction, we are assuming this direction as positive. This Q1 and this Q2. If answer comes negative, you change the directions. If it is positive, then assume directions are okay. So degree of indeterminance is 2. So Q1 and Q2 let's select. So first remove this and obtain. So I'll draw the smaller diagrams now. Say 40 kilonewton meter. What will be the diagram due to this is, so I will draw the diagrams, bending moment diagram here, okay. Now if this is the reference line, 40 is constant, so and it produces tension downward. So on tension side, this is 40, this is also 40. Then this is constant for this also. So this is 40. Okay. And inside we take positive. So this diagram is positive, this diagram is positive. So this diagram is called M upon EI diagram. M upon EI diagram. Now next diagrams, let's draw. So now I will draw here. Say apply unit load here, 1, and this is fixed, remember. What will be the diagram? So diagram will be no variability on this, tension produces on this side, and this is the diagram. This is 1 into 4, so this ordinate is 4, outside minus. This ordinate is 4, outside minus. And next, let's consider for this is apply here unit load, and your diagram will be like this. 1 into 3, this is 3, and for this it is a rectangle. This is 3, this is 3. This is plus, because inside. And this is outside, this is inside. So now let's find out dQ1L equal to area of M upon A diagram. So this is M1 diagram. And this is M2 diagram. So this will be equal to, now here we have only vertical this. So consider only vertical. Height base is 4 into 40 upon EI. So we have to divide here by EI in order to get M upon EI diagram. Multiplied by ordinate here is 2, that is 4 by 2. So this you will get dQ1L. Then dQ2L equal to, now here we have both, this is 4 into 40 upon EI into height is 4, it's again 4 by 2 because its CG is half, plus, both are positive. Now here this area positive, this ordinate is negative, this is negative, that means you will get this minus. Now here this area is 3 into height is 40 upon EI, and ordinate at its CG is again half, so it's this is 3 by 2, 3 by 2, ordinate is 3 by 2. Here 4 by 2, 3 by 2. Now you do the calculations, you find out. So this will be positive. Next, F11 equal to, only this figure we have to take into account, minus 1/2 base height, 4 upon 1/2 base height. And its CG, 2/3 of their base means CG will be minus 2/3. That's all. So this is plus, CG will be 2/3. Because it's a sinusoidal distance, suppose this is, so this distance is 2/3 of base. So height divided by height, no, this divided by 4 equal to this divided by 4, so this is 8 by 3, not, so this is 8 by 3. Then means this ordinate is 8 by 3. F12, F21 equal to, now area of one diagram, let's take this triangle area, minus 1/2 base height divided by AI into ordinate is 3, because that is a rectangle, everywhere ordinate is 3. And the last F22 equal to area, base is 4, height is 3 upon EI, ordinate is 3, plus, now triangle 1/2 base height 3 upon EI, and what is the ordinate of triangle at its own CG, that is 2/3 of base. So here this CG, this ordinate, so this distance is 2/3 of their base is 3, 3 gets cancelled. So this divided by 3 equal to this divided by 3, so this is 2. That means ordinate is 2. So you find out this. So we have calculated all the displacements, and finally using compatibility conditions, dq1L, F11Q1, F12Q2 is equal to 0. So you will get first equation, then dq2L plus F21Q1 plus F22Q2 is equal to 0. You will get second equation. So solving 1 and 2, you find out Q1 and Q2, and after getting Q1 and Q2, then reactions at A, moment at B, everything can be calculated just by using equilibrium conditions, and then you construct bending moment, final bending moment diagram for the given frame. So friends, we have seen two frame problem, one continuous beam problem, and the problems on propped cantilever beam, fixed beam. So that means applications of flexibility to indeterminate structures, statically indeterminate structures like propped cantilever beam, fixed beam, then continuous beams and portal frames that we have completed. So now we will stop here. So assignment on flexibility method will be given to you. You solve those problems, and then next time we will start stiffness method. So thank you very much.